Good evening, I'm Lisa Brown and you're watching Local 12 News. I begin tonight with the story of 4 local students who attend Clinton Massey High School and their treacherous journeys through the course of the year regarding pre-calc. Now over to Jim, who is interviewing a student.
Thank you, Lisa. I'm here with Courtney who has a little bit of work done with 4 students from Clinton Massey and their statistics on how they did. Throw it over to Courtney now.
Cara went up. 29% of her mistakes were computational, 57% were conceptual, 4% were error in communication, and 3% were error in reasoning. Me, I missed 29% in computational, 58% in conceptual, 13% in error in communication, and 0% in error in reasoning. Preslee Rolfe missed 11% in computational, 77% in conceptual, 8% in error in communication, and 4% in error in reasoning. And Thomas Williams missed 25% in computational, 43% in conceptual, 16% in error in communication, and 16% in error in reasoning. So it's safe to say that everybody missed the most in the category of conceptual, as you can see here. And everyone missed the least amount in error in reasoning.
Thank you, Courtney. That was really good. Now we're going to throw it off to Preslee and Cara to do some math problems.
So our first problem is given the points 13, 17, and -12, -18, find the distance and midpoint. So this is your distance formula and there's your midpoint formula. So when you plug your points in, it'd be the square root of -12 minus 13 squared plus -18 minus 17 squared. And then -12 minus 13 is -25. And then -18 minus 17 is -35. So you square both of those. And then when you add those and take the square root, it'd be 5 squared is 74. So that's your distance. And then for your midpoint, you just do x1 plus x2 over 2, which is 13 minus 12 over 2. And then y1 plus y2 over 2, which is 17 minus 18 over 2. And when you simplify those, it's 1/2 and -1/2. So there's your midpoint.
Alright, so you have to find the difference of quotients giving that f of x is equal to x squared minus 2x. And your difference of quotients is f of x plus h minus the f of x over h. So when you do that, when you plug everything in, you get x plus h squared minus 2x plus h minus x squared minus 2x over h. And then you get x squared plus h squared plus 2xh minus 2x minus 2h minus x squared plus 2x over h. Yeah, h. And then when you simplify that, so these will cancel and these will cancel. Left with h squared plus 2xh minus 2h, and then this will change to, and this will cancel and give you an h, and then plus 2x minus 2.
Is everyone able to keep up with that? If so, well done. We're now moving on to chapter 2 with Courtney.
Okay, so this question is a part of the chapter 2 test. It says use synthetic division to divide 6x to the 4th minus 4x cubed minus 27x squared plus 18x. When you go down, you fill in the constant of each term, but since there's not just a constant at the end, you have to fill in a 0. Your first step is to drop the 6, so 6 times 2 is 12, and then you add these 2 terms, so you get 8. 8 times 2 is 16, add these 2 terms and get -11. 11 times, or -11 times 2 is -22, and you add them and get -4. And 2 times -4 equals -8, and when you add them you get -8. So when you write your answer, the power is going to be 1 less than what you started with, so you get 6x cubed plus 8x squared minus 11x minus 4. And this is your remainder, so you say plus -8 over whatever you divided by, which is x minus 2 in this case.
Alright, that was really good, Courtney. Now we're going to give it to Cara, and she's going to find the real zeros for you.
Alright, so the problem is to find the real zeros of f of x equals x cubed plus 4x squared minus 4x minus 16. So I factored by grouping, and I pulled out an x squared and then that would leave me with x plus 4. And then when I pulled out a negative 4 on this one, I got x plus 4. And then you take these two terms and put them as a factor, and then these factors are the same, so you can just do it once. So you have x squared minus 4, and then x plus 4 equals 0. You set them both equal to 0, and you get x is plus or minus 2, and x is negative 4.
Now we'll toss it over to Tina the Fat Lord, who's interviewing passerbys on the street.
Our first contestant. Yeah, do you feel comfortable using the one-to-one property?
Nah, fam, I don't even know what that is.
Alright, we'll bring it back to our students in the studio to help us figure it out. Does anyone know how to solve this using the one-to-one property?
One-to-one, I love that stuff! Well, you see here, since you have log 8 and log 8, you just drop them and it becomes 3x minus 10 equals 5. Then you just solve for x by adding 10 to both sides and then dividing by 3. So that leaves you with x equals 5.
On to our next victim. Hi, what's your name?
I'm Casey.
Well, let's math. Can you tell me how to expand the expression of log base 5, 5x squared?
Please, I can do that in my sleep. Because you're multiplying the two terms, you will use addition to expand. The commonly missed error is that people don't move the exponent to the front. The answer is log base 5 of 5 plus 2 log base 5 of x.
Nicely stated, young lady. That's indeed the correct answer. Back to you, Lisa.
Alright, now we have to graph a cosecant function. To find the amplitude, you have to take the absolute value of the number in front, so 2. To find the period, you have to set what is inside the parentheses underneath 2 pi. And then the 2's will cancel, leaving you with just pi. And then to find the x scale, you have to take the period and divide that by 4. So pi over 4. And that'll be your x scale and what you count by. Now we're going to have our expert grapher.
Okay, so your x scale or your interval is pi over 4. So you're going to count by pi over 4. And so you have pi over 4, and then you have 2 pi over 4, which is pi over 2, and then 3 pi over 4 and pi. And then on this side, you just make it negative. And since cosecant is the inverse of sine, we're going to graph the sine function first. And sine starts on the line, and then since you have negative 2, you have to flip the graph. So usually it goes up first, but now it's going to go down first to negative 2, and then back up, and then up 2, and back down, and then over here you'll go up, down, and back up, and you connect your lines. And then now we have cosecant, so to find that, you draw an asymptote at every time you have a dot at the x-axis, so, or your x-intercepts. So there's one, there's one. And then you just draw a separate parabola right here, going close to the asymptotes but never touching on each one of these.
Very good. Now we are going to wrap up this evening's show with what the students have learned and what improvements will be made.
Through this project, we as a group learned to take our time on tests and focus on little mistakes like sign errors and other major computational mistakes.